What is C++? It is a programming language created by Bjarne Stroustrup in 1979. It started as an extension of the C language, adding classes, objects, and powerful new features for building fast and reliable software. C++ is a compiled language. You write source code in a text file, the compiler translates it into machine code, and the computer runs the program directly. This is why C++ is so fast. Here is a simple example. The program includes a library, defines a main function, and prints "Hello World." The compiler reads these lines, builds an executable, and the screen shows the message. C++ supports object-oriented programming. You define a class, create objects from it, give them data, and call their methods. This helps you organize large programs into clean, reusable pieces. C++ gives you control over memory. You can request memory with new, use a pointer to access it, and free that memory with delete. This power makes programs efficient, but requires careful handling. The standard library gives you ready-made tools. Vectors store lists of items, strings hold text, maps link keys to values, and algorithms sort and search your data. You build faster by using these tools. Where is C++ used? It powers game engines, operating systems, web browsers, financial trading platforms, and embedded devices like cars and robots. Anywhere speed and control matter, C++ shows up. To start learning, install a compiler, pick an editor, write your first program, and practice small projects. Step by step, you will master C++ and build powerful software. Every C++ program runs on data, and every piece of data has a type. Types tell the compiler how much memory to use and what operations are allowed. Today, we explore the main types in C++, starting with the built-in primitives. First, the primitive types. An int holds whole numbers, like 42. A float or double holds decimals, like 3.14. A char holds a single character. A bool holds true or false. These are the basic building blocks. Next come derived types. An array stores many values of the same type. A pointer holds a memory address. A reference is an alias for another variable. These types build on the primitives to give your program more power. User-defined types let you design your own data. A struct groups related fields together. A class adds methods and access control. An enum lists named constants. These types model real-world things inside your code. C++ also supports modifiers. Signed and unsigned change whether a number can be negative. Short and long change the size in memory. Const makes a value unchangeable. These modifiers fine-tune how a type behaves. Modern C++ adds the string type from the standard library. A string holds text, like "Hello World." It grows and shrinks automatically, so you do not manage memory by hand. Strings are safer and easier than raw character arrays. The auto keyword lets the compiler figure out the type for you. The void type means no value, often used for functions that return nothing. Together, auto and void give you flexible control over how types are declared. So C++ types come in 4 families: primitives, derived, user-defined, and modern library types. Pick the smallest type that fits your data, use const when you can, and lean on string and auto for cleaner code. Why do so many engineers still choose C++? It powers game engines, browsers, trading systems, and operating systems. The advantages of C++ start with raw speed, deep control, and a massive ecosystem built over decades. First, performance. C++ compiles directly to machine code, skipping interpreters and heavy runtimes. A tight loop in C++ often runs 10 times faster than the same loop in a scripted language, making it the default for performance-critical work. Second, deep control over memory. C++ lets you choose the stack or the heap, manage lifetimes with smart pointers, and place objects exactly where you want. This control is essential for embedded chips, robotics, and real-time systems. Third, zero-cost abstractions. You write clean classes, templates, and generic code, and the compiler strips away the overhead. The final binary runs as fast as handwritten low-level code, but your source stays readable and reusable. Fourth, a powerful standard library. The standard template library gives you vectors, maps, sets, and algorithms that are fast, tested, and portable. You stop reinventing data structures and start solving real problems. Fifth, portability across platforms. The same C++ source can compile for Windows, Linux, Mac, mobile phones, game consoles, and tiny microcontrollers. Write the logic once, target nearly every device on Earth. Sixth, multi-paradigm flexibility. C++ supports procedural code, object-oriented design, generic programming, and functional style. You pick the right tool for each problem instead of bending one paradigm to fit everything. Finally, a huge community and long-term stability. 40 years of libraries, tutorials, and battle-tested code back you up. Learning C++ gives you a skill that runs everything from rockets to databases, and it is not going. C++ is a fast, powerful language used to build serious software. From games to operating systems, from browsers to robots, C++ runs the world's most demanding programs. Let's explore what you can actually build with C++. First, video games. C++ powers game engines like Unreal and Unity's core. It runs the graphics, the physics, and the player input loop. That is why most console and PC games choose C++. Next, operating systems. Parts of Windows, macOS, and Linux are written in C++. It talks directly to memory and hardware, so it can manage files, processes, and drivers at top speed. C++ also builds web browsers. Chrome, Firefox, and Safari all use C++ for their rendering engines. It parses HTML, runs JavaScript engines, and paints pixels fast enough to feel instant. In robotics and embedded devices, C++ controls the action. It runs on drones, self-driving cars, and microcontrollers. The code reads sensors, decides what to do, and moves motors in real time. C++ powers finance and trading systems too. Banks use it for high-frequency trading, where every microsecond matters. The code reads market data, runs strategies, and sends orders before competitors can blink. You can also build creative tools. Photoshop, Blender, and many audio plugins are written in C++. It handles heavy image, video, and sound processing without lag, even on huge project files. So what can you make in C++? Games, operating systems, browsers, robots, trading systems, and creative tools. If a program needs raw speed and direct control, C++ is still the language to reach. Should you learn C++ in 2026? A new programmer stares at a long list of languages: Python, JavaScript, Rust, Go, and C++. The question is simple, but the answer shapes years of career choices. C++ still powers the systems we rely on every day. Game engines, browsers, operating systems, financial trading platforms, and embedded chips all run on C++ code. When speed and control matter most, C++ shows up. C++ teaches you how the machine really works. You see memory, pointers, the stack, and the heap. Most modern languages hide these details, but understanding them makes you a stronger engineer in any language. But C++ is hard. The syntax is heavy, memory bugs hide for weeks, and build systems can feel painful. New programmers often spend more time fighting the compiler than shipping features. In 2026, the job market splits. Web, mobile, and AI work mostly use Python, JavaScript, and Swift. But systems, games, robotics, and high-frequency trading still pay top salaries for strong C++ engineers. Modern C++ is also better than it used to be. Smart pointers, auto types, lambdas, and modules cut the old pain. Tools like CMake, Clang, and sanitizers catch bugs before they ship. So here is a simple rule. If you want web, mobile, or data jobs, learn C++ later. If you want games, systems, embedded, or trading, learn C++ early. Either way, read C++ at least once to understand the machine. C++ is not required to start a career in 2026, but it is still one of the most powerful skills a programmer can own. Learn it, and the rest of computing becomes easier